And that's all. Is that true? Are you there, my daughters?
Yes. Yes, we are here.
So, when you take a solid, that's sugar. Solvent, that's water. Get a solution. And that can be homogeneous, isn't it? If you take a powder, like if powder material whether for uso, I don't know if you call it, then you add water. It will not dissolve easily. It becomes coarse. And if you shake thoroughly, it might become somehow like a solution, but it's not a solution, it just becomes so when we talk of solutions, and talk of homogeneous, as a few solutions. That is, the solute dissolves the solvent. Sugar has water that is soluble. Some items, like some of the chemicals we have tablets, highly soluble in water. I don't think this simple one we are using is a solution for me. It's not a solution. Of course, the experiments which are there, the items used to make supplement, we have the carriers, we have the killer materials, they are not soluble. So it will not be a continuous one. So that becomes a homogeneous. So the next step, those are the correct homogeneity. Something even with these are simply the possibility to write one dictionary. Heterogeneity, something not dispute even with its cluster, not a single case as in the case of American or across discussions. A solution is a homogeneous mixture of two or more substances. Or a solution is a homogeneous mixture of solid and a solvent. Or a solution is a homogeneous mixture of two substances that consisting of one phase. We're going to look at the monophase and biphase. A solid is dissolved in a solution. A solid is a substance within the solid. Solid is the liquid within the solid is dissolved. An aqueous solution has water as a solid. So when you have an aqueous ring, it means it is water in the oil. They have put the items in the oil, but they have been made with the water as the main item. So it is actually so that you can use water to clean the diamond solution. A homogeneous mixture consisting of one phase and containing only two components, one solid and one solid. Solution of sodium chloride in the water. That is a binary solution. Two items. A binary solution, a really simple solutions. A solution containing relatively small quantity of solid as compared to the amount of solid. Strong TNT, concentrated solution. A solution containing large amount of solid in the solution, but in the liquid, and that is a dilute solution. Like sodium chloride, you can have what we call hypertonic salad. That's when add salt, it dissolves. Add more, doesn't dissolve. Add more, when it appears at the bottom. What do? You boil it. When you boil it, it dissolves. The higher the temperature, the higher that becomes now dry. Same with sugar. If you put 2 teaspoonfuls salt, you put more, very sweet. You put 6, that's it. What do? You boil. When you boil, salt. If you continue boiling, you become a color. Yeah? Okay. When you have unsaturated solution, a solution in the liquid, more slowly can be dissolved.
Excuse me, sir.
Yes, ma'am.
Your voice is a bit, it's very low. I don't know why.
I try to adjust my sitting position. Now let's see. Dilute solutions that we have had, and saturated solution, a solution in which more solid can be dissolved at a given temperature is called as unsaturated solution. But if it's saturated, a solution is one where the concentration is at a maximum. No more solid is able to dissolve at a given temperature. A saturated solution represents an equilibrium. The rate of dissolution is equal to the rate of crystallization. The solid continues to dissolve, but crystallizes at the same rate under these conditions. The number of molecules leaving the solid is equal to the number of molecules returning to the solid phase, i.e. solid. For any of you who might have a chance to go to Makadi, I don't know whether you ever have a chance in your lifetime. If you go to Makadi, that's in Kajiado, there is a small lake there. It is almost 5 square kilometers. And that's where we get Makadi salt. And I hear also in Mombasa there is one side of Makadi. I'm not sure on there. That's where they get the salt. Now, daytime, it looks very fresh water. It looks like water, no problem. But then, on the other side, you find it is a stone. As the temperature becomes low, everything becomes solid. It's just Makadi. Makadi is the magnesium sulfate or sodium sulfate. Which one is it, Makadi? And we go to all of us and find it's Makadi soda. That's where you find the Makadi soda. Makadi soda ingredients. Ingredients. And Makadi soda, what does it contain? Normally Makadi soda, what does it contain? Makadi soda, ash and silica, sodium sulfate cancer, sodium plus silicon. Actually, I know it's some sodium sulfate or something like that. In fact, nothing is very much more than salt. You can be able to extract salt from that. Now, at night, the temperature goes down, then there's a lot of what happens becomes solid. Like daytime, when the temperature goes high, it dissolves. But daytime is when they start harvesting. They use a tractor, caterpillar, to cut off the stones, and then they grind in it also. So that's where you have a problem of saturation and unsaturated, etc., etc. Super saturated solution. A solution that contains relatively large amount of solid and that required for saturation. It's prepared by heating and adding more and more solid. You have come across something called syrup simplex, the one we are using to prepare syrups for children. Syrup simplex is 66% sugar. That is also gross. That is, you measure 67 grams of sugar in 100 ml of water. Or you measure 670 grams in 1 liter of water. Then you boil up to a certain temperature. There are things that you'll be able to watch. We shall do that in the lab. Make sure you remind me up in the lab to say I will prepare the syrup complex. That's when you are preparing a super saturated solution. And that's what we use for preparing syrups for children. With a certain pressure. So types of solutions based on physical states of solid and solvent. Gas, solvent would be gas. State of solid would be gas. Example, air. State of solution, liquid, liquid. State of solid, gas, oxygen, water. These are just examples. Solutions. How does a solid dissolve into a liquid? What drives the solution process? What are the energetics of the solution? It simply says that it means the solvent has got pores. This water that you are seeing, the water that you are using, has got pores, equal space in between. If you look at the structure of water, H2O, it has got a dash or another dash or then to H. There is a space in between. So you expect a solid to fit in between. How does a solution form? Solvent molecules attract to surface ions. Each ion is surrounded by a solvent molecule. Enthalpy, is it enthalpy or we're calling it enthalpy, changes with each interaction in broken or form. Energy is released. We used to call it entropy, not enthalpy. I think it was entropy. I remember when I was younger, it was entropy. That's when you generate energy. How does the solvent form? The ions are solvated, surrounded by solvent. If the solvent is water, the ions are hydrated. In the molecular force here is ion dash diamond. Two links. A bond between the solvent and a bond between the solid. Dissolution versus reaction. What is dissolution? Dissolution is a physical change. You can get back to the original solute by evaporating the solvent. So if you put salt in the water and you want your salt back, you simply do evaporation. Put in a jar, start boiling slowly. As the water evaporates, the salt will remain. The same amount you put there, if it's 1 kilo, you get 1 kilo. Original solid by evaporating the solid. If you can't, substance did it, so it reacted. If you cannot be able to take back the salt, it means the solvent and the solid reacted. E.g., if it was sodium chloride and you dissolve it in hydrochloric acid, however much you evaporate can come out because sodium reacting with hydrochloric acid, you get sodium chloride plus water. So however much you try to dissolve it to evaporate, there's no way sodium chloride will be broken. It will just remain a solution. So when we talk of dissolution, it means the two items can be separated or evaporated. But when we talk of reaction, it means there was a reaction between the solvent and the solid. Sodium chloride plus hydrochloric acid or sulfuric acid indicates sodium sulfate plus water. Now, there's no way you can evaporate to get sodium back to sodium chloride. That means there was a reaction. I think degree of saturation. What time is it? Like that. Saturated solution. Solvent holds as much solid as it is possible at that temperature. And dissolved solid remains in plastic. Dissolved solid is in dynamic equilibrium with solid particles. Degree of saturation. Unsaturated solution. Less than the maximum amount of solid for that temperature is dissolved. No solid remains in plastic. Degree of saturation. Those are the diagrams. Initially, it's very straight, very clear. Now just read the maximum. Then as you add more, it becomes it's not solid anymore. Solvent holds more solid than is normally possible at that temperature. These solutions are unstable. Crystallization can often be stimulated by adding a seed crystal or scratching the side of the plastic. I hope you're going to be able to do that experimentally in the lab. Stages of solution process, separation of solid. Must overcome the equilibrium or ion attraction in solid requires energy and time. To separate a solute from a solvent, you must use energy. Separation of solvent must overcome the equilibrium process of solvent particles. Requires energy again. You require energy to separate a solid from a solvent. But you cannot separate a solid from a solvent if there was a reaction between the two. Dissolution at the molecular level. Consider the solution of sodium hydroxide in water. It will not work, isn't it? If you look at the formula, sodium hydroxide plus water, how do you separate the two? You must use a lot of energy, it is quite expensive. You must use a lot of energy to separate so that you get sodium alone and water. But sodium is highly positive. It will react with anything that is nearby. So that doesn't work. Types of heterogeneous Moser mixtures. Oh, sorry, the other guys are sending the messages. types of heterogeneous mixtures, that means the mixture is not clear. It does not dissolve properly in the solvent. And that's what we call as a suspension. A suspension is a mixture in which particles of a material are at its passed around a liquid or a gas, but are large enough that it is settled out. Example, antacids. Antacid preparations. The ones we make ourselves in our other items you get from pharmacies like Rico, like Denmark. We always say shake before use because it's a suspension. And whenever you're using a suspension, it means you're using a suspended agent. A suspended agent does not dissolve in the solid. So the particles in suspension are large enough to scatter or blow light. A suspension can be separated by passing through a filter. Suspension. Different components have different phases, such as solids in liquids or liquids in gases. It is necessary to shape the substance before. That's why all suspensions will do shake well before use. Colloids is a mixture in which the particles are spread out but are not large enough to separate out. The particles are not as small as those of us, however, are smaller than those of a suspension. A colloid. Particles in a colloid are large enough to scatter light. A colloid cannot be separated by passing through a filter. They consist of two separate phases, a disperse phase or internal phase, and a continuous phase or dispersion phase. Lectures a bit. So, the lectures are out in your college by 10. They are people from the office. So, college consists of two phases, the continuous phase and the dispersion phase. Some are transformed because of the Tyndall effect, which is a scattering of light. Examples are given there, homogeneous colloids like this. This was accepted, so I have no problem. We shall continue from there about heterogeneous mixtures in the academic. Right? That's what we shall continue from next time. It doesn't mean next week. It's just going to be this week. I'll call on you and you tell me. But the next meeting we are going to have will be in pharmacognosy. Then the other meeting will be ethics in whatever. I'll try as much as I can. I also have my presentations for my PhD. They are very, very difficult. So I have to prepare yours, I have to prepare for the other classes and the other colleges under myself. And I have to say as prepare.